We're trying to develop the technologies that will accelerate the adoption of wireless charging and electrified transportation.
So this technology can be more affordable for everyday vehicles, not just for the luxury segment.
So major automakers, major energy companies from around the world, not just in the United States, they come to Oak Ridge because they understand in principle they're going to get the best of the best.
Hello, everyone, and welcome to The Sound of Science, the podcast highlighting the voices behind the breakthroughs at Oak Ridge National Laboratory.
We are your hosts, Morgan McCorkle
and Jenny Woodbury.
Think about the technologies you use on a daily basis. A smartwatch, a smartphone, wireless earbuds. We've come to rely on these devices for our personal and professional lives.
Now think about a time where you forgot to plug in one of these devices and how annoying it was to realize it was dead when you were ready to use it.
We love the convenience these devices bring to our lives, but sometimes charging them can get lost in the shuffle.
A dead phone is one thing, but if you drive an electric vehicle and forget to plug it in, that's probably going to have a bigger impact on your day.
The thought of a drained battery also provokes so-called range anxiety for some would-be EV adopters who might hesitate to transition from a gas-powered vehicle to a more sustainable option.
Scientists have been looking into wireless charging to improve the convenience factor and to address those lingering concerns about how far a battery-powered car can take you.
In fact, wireless charging devices already exist on the market for some smaller electronics. You simply lay the device on a charging pad and voila, no cords necessary. But it takes a lot more power to charge up an electric vehicle than it does for a phone or watch.
And that's what researchers at Oak Ridge National Laboratory are focused on: high-power wireless power transfer for electric vehicles.
While the idea of wirelessly charging something sounds futuristic, the idea was first conceived more than 100 years ago.
Nikola Tesla actually had the very first experiments of the wireless power transfer. So there were actually some public experiments that he was running. And at the end, he was able to transfer power wirelessly and turn on a light bulb or, some low power device. He wanted to increase the power transfer distance. And he had an idea of transmitting power from New York, from United States to Berlin, Germany, all wirelessly. And the way he was describing the technology, it won't be just power. You can actually send a text message, you can send a picture, you can communicate with your customers in the other continent. So he was pretty much describing today's internet and, wireless communication technologies that we have today.
That's Omer Onar. He's one of the researchers pioneering high-powered wireless charging technology at ORNL.
But Tesla's dream of long-distance wireless power transfer didn't pan out, partly because of funding, and partly because the technology he'd need to achieve it didn't exist yet.
They didn't have power electronics back in those days. So he was limited to the grid voltage and grid frequency, which is, 60 hertz, very, very small. So he had only one option to increase the voltage. So he designed those voltage folding circuits to get to the really high voltages. But there were some undocumented but witnessed experiments that he was able to turn on some fluorescent lights from about 2 kilometers of distance with high efficiencies. But we don't know if that's really true or what was the physics behind it. He was able to actually transfer power between a transmitter and the receiver wirelessly.
In the 21st century, the team at Oak Ridge is well equipped to tackle this challenge. For more than a decade, they've been experimenting with and refining wireless charging technology.
The driving force behind ORNL's wireless charging research has been Barak Ospenagy. He leads the lab's Vehicle and Mobility Systems Research section.
In 2008, Barak's interest was piqued by a workshop that discussed ways to charge EVs on the road.
The idea at that time was they were focusing on electrifying roadways, and the idea was having this vehicle have an arm on the side of the vehicle, and that would be engaged and it would be coupled with the rail on the side of the road, and that's the way they would power the vehicles. I didn't think that was the best approach for this, so I said, okay, are there any other ideas, are there any other approaches we can go after? So I did a quick search and then came across this MIT newsletter, and there they were talking about wirelessly powering cell phones. So that gave me the idea of maybe we use wireless charging for electrifying vehicles while they are being driven on the highway.
What Barak and his colleagues came up with is a set of charging plates, one mounted under the vehicle and the other one on the ground. Inside each plate is a coil. When the plates are aligned, power is transferred between them.
So in terms of the underlying physics of the power transfer principle and the basic building blocks, it's all the same. You take energy from the grid, you have power electronics, which converts it into high frequency AC, which generates the magnetic field. And that field is generated by the transmitter coil, which is on the ground. And on the underside of the vehicle, you have a receiving coil, which links the magnetic energy and absorbs the energy and charges the battery.
That's Veda Gallikagray. He leads the Electric Drives Research Group at ORNL.
The team at Oak Ridge is working on two types of wireless charging, stationary and dynamic. As you probably guessed, stationary charging applies to when the vehicle is parked. For dynamic, the vehicle would charge as it moves over an electrified roadway.
With both methods of charging in play, Barak envisions a future that could sound something like this.
Let's say you come home from work and you park your car in the garage, or maybe the car parks itself. You don't worry about plugging your vehicle. And in the morning you get up, the car is fully charged, and you drive to work. The highway is electrified, so it can give you enough energy to your vehicle so that it will offset the energy needs while you're driving. So you get off the interstate, you come to work, you never have to worry about plugging your vehicle. The vehicle charges at home, the vehicle charges at work, and if we have this vision accomplished with wireless charging everywhere, then we never have to worry about plugging in. If we have this, we can reduce the size of the batteries that would be needed for vehicles. And that will also help with the reduction of the cost of the electric vehicles, because that's something we always hear about.
While it may take some time for that vision to become a reality, ORNL has made significant strides in that direction.
One of the main goals of wireless charging is to make powering up an EV as easy and convenient as gassing up a car.
Charging an EV can take anywhere from 30 minutes to 12 hours, not exactly a gas-and-go situation.
Right now, the team is aiming to reduce that time to 15 minutes for a full charge.
Getting the charge time down isn't just a win for convenience, it's also a step towards a greener era in transportation.
To address the climate change needs and also for decarbonization, we're looking at accelerate the adoption of electrified transportation. As a part of that, we're working on wireless charging for convenient and fast charging and to eliminate range anxiety.
The way you reduce the charge time is by increasing the power on the charging system.
Over the past decade, the team has been researching how to do this for both stationary and dynamic charging.
As you can imagine, this kind of work takes a pretty unique lab space. We asked Omer Onar to share with us what it's like.
We spend a lot of time at the lab because we need to have experimental validation and demonstrate the operation of the technologies that we develop. So at the laboratory, there are several things. Of course, the units, the hardware prototypes that we build, but also the source and load emulators, an electric vehicle battery emulator, an input power source, which is usually a grid emulator, and all the instrumentation devices, including oscilloscopes and power analyzers, to actually characterize the system, to demonstrate the operation, to analyze the operation and see how we can improve the control system or the things that we did on the hardware prototype. So in addition to the hardware, we also have the instrumentation, power analyzers and oscilloscopes. Here at ORNL, we really have unique capabilities in terms of the equipment and facilities to get to the target operating conditions that we all dream about. So we are really blessed for that opportunity to have state-of-the-art equipment and instrumentation that we have to validate our hardware prototypes.
Omer's research primarily focuses on stationary charging, while his colleague Veda works on the dynamic side.
While a lot of the technology for both methods overlap, charging a moving vehicle creates some additional complexity.
So the underlying principle and the building blocks are more or less the same, but in stationary, you're stopped. So you have a lot more time to control things. You can charge it, start up the charging process slowly. You can charge. There is no movement, so you don't have to worry about, is the linkage going to change? Is the efficiency going to change? What's going to happen? But in dynamic, because by nature, it's continuously moving. And if it's on the interstate, it's 50, 60 miles an hour. If somebody's driving slow, it could even be 75 or 80 miles an hour. So you have like milliseconds window to detect the vehicle, start the power transfer efficiently, safely, and then shut down. So everything needs to be done very quickly, and everything needs to be controlled very quickly in a safe manner.
Since roadways with embedded wireless charging systems don't exist yet, the team has built a test rig in the lab to simulate charging a moving vehicle.
We've done quite a bit of stationary charging experiments, as you know, like demonstrations, not just experiments. Now, in dynamic charging, we need to go to a vehicle integrated unit and the roadway. As an intermediate step, we developed state-of-the-art dynamic charging test rig in the lab. We have complete wireless power transfer system attached to it, and we've started testing the system in the lab. So the moving unit is mimicking a vehicle, and we're looking at the power transfer profiles and optimizing our controls so that it does what it's supposed to do.
The setup for stationary charging is not nearly as elaborate and is easier to imagine as something you might one day have in your garage. Here's Barack again to describe what that would look like in that setting.
If you think about the wireless charging system in your garage, system includes a box that's on the wall possibly, connected to the grid, and then this box feeds a coil on the ground, which would be under the vehicle, and this coil could be buried in concrete or it could be on top of the concrete. I prefer it buried, as invisible as possible. So when the box powers the coil on the ground, that generates electromagnetic fields that you transfer the energy into the coil that's under the vehicle, and that coil connects to another box on the vehicle that converts this energy back to the direct current energy that would be needed to charge the battery.
This hands-free setup would be a dream for EV owners, but you may be wondering if it's safe to have something like this in your garage.
That question brings us to what Barack calls the cat problem.
When we have tours in the lab, one of the questions I get usually is, what happens if a cat goes under the car in between the coils? Of course, that's something we have to worry about. It doesn't have to be a cat. It can be a toddler or something else. The funny way I answered the question is that, the cat is not tuned to the resonant frequency of the wireless charging system. There shouldn't be any problem. And, the cat would be well and, live a long life. So with that in mind, we have been looking at ways of, how can we detect if there's an object? It doesn't have to be a cat or a toddler. It could be some other object. If we can detect the object by different ways, we could actually stop the wireless charging process.
Barack says they closely monitor the safety of the passengers inside the vehicle as well.
We're going by the standards that are out there, which tells us what kind of electromagnetic field strengths we could have at certain locations inside the vehicle or around the vehicle. So when we are actually demonstrating our wireless charging systems, we have these sensors for us to measure the electromagnetic field in different parts. And for example, 120 kilowatt system, we realized after measurement, we were much below the standard limit. So, we were happy about that. And eventually, since we were going to go to higher power levels, we want to make sure we stay under the limits. That's when we started looking at shielding technologies. All we're trying to do is confine the electromagnetic fields inside the cylinder formed by the two coils.
The team's tireless work on this technology has produced some exciting milestones. In 2016, they achieved their first successful wireless charging demonstration.
As a part of a DOE project, we developed a 20 kilowatt wireless charging system through a 6-inch gap. And actually, the goal was 6.6 kW, but we were able to go 3 times the power we targeted. And we were able to show we could do this at really high efficiencies, around 97%. And actually, the same vehicle we also used to show at very low speeds, we could do dynamic wireless charging. The original goal was stationary wireless charging, but then we added the dynamic portion of it just in the lab, running at just a few miles an hour to show that this will work. And after that, after the demonstration, we were able to push the power up to 35 kW. We were just trying to see, with the existing setup we had, what kind of power levels we could go to.
2 years later, they demonstrated a 120 kilowatt wireless charging system.
This milestone was quite the feat, but it also brought to light a new challenge.
The team had been so focused on upping the power, they didn't take into account that the technology they were using for the transmitter coil was adding a significant amount of weight to the vehicle.
The coil we designed for 120 kilowatt application was actually 120 pounds. So that's almost like a passenger added to the vehicle. So that's when we said, okay, we have to do something about the coil, and we start looking at different options for it. We were using a single phase, double D coil. That was the standard, most people were using. And we said we could come up with a different design. That's when, we had our electric motors researchers get involved. And then working with our wireless charging folks, we came up with the Polyphase Coil, which is a 3-phase coil with rotating magnetic fields, just like an electric motor would work. In this case, of course, we're not rotating the coils, but using this technology, in a single-phase system, we would have really high currents going through the coils. In a polyphase system, we would need smaller currents because we have 3 phases and currents from three phases or the electromagnetic fields from three phases added up. So with that, with lower peak currents, we can actually reduce the size of the coil maybe by half or maybe a fourth. So that has been the exciting thing about polyphase coils we've been working on.
In addition to the polyphase coils, the team has also improved the system with a new technology they've dubbed the Oak Ridge Converter. Here's Omer again.
The other thing that we want to achieve is the cost. So we have a new technology that we call Oak Ridge Converter. So that eliminates one of the power conversion stages in wireless power transfer systems. So that's offers about 30 to 50% reduction in size, weight, volume, and cost of the power electronics for the wireless power transfer technologies. So this technology can be more affordable for everyday vehicles, not just for the luxury segment. And this can be more easily implemented for production vehicles. And it goes above and beyond the research space, and it becomes a part of our daily lives.
The improvements they've made to the technology has the team ready to push for even higher power demonstrations.
Scaling up to a 300 kilowatt system is Barak's next goal, but not many EVs on the market can handle anywhere near that level of power.
Thankfully, ORNL's research in this area has attracted a lot of attention from automotive industry partners looking to research this technology for future use.
One of those partners is Volkswagen Group. The German automaker had just the electric vehicle to send to ORNL to test out the higher power system, the Porsche Taycan.
So they shipped us one of their vehicles from Germany, and it's now sitting in our lab. And we're hoping that, I think by this summer or early fall, we'll be demonstrating 270 kilowatt wireless charging, because that's the maximum they can accept in this vehicle. So we're really excited about this opportunity and collaboration.
We as Volkswagen Group Innovation, as we do research for all brands like Porsche, Audi, Volkswagen itself, we're always looking into what's the next step. And high power wireless charging is definitely something that is of interest for us, since up to now, most of the commercially available solutions are rather low power.
The last voice you heard was Rüdiger Kusch. He's an engineer with Volkswagen Group Innovation in Germany.
He and his colleague, Hendrik Meinke of Volkswagen of America's Knoxville Innovation Hub, are working with the Oak Ridge team to see how this technology could be used in the future for Volkswagen's brands.
Wireless power transfer is on our radar for many, many years, and we have developed a low-power system in the past. So there is always concerns when it comes to mass volume production on the cost and on interoperability. So what's the landscape right now is that several suppliers offering wireless power transfer systems with different coil geometries, and they don't work with each other. They are not interoperable. So that's a big advantage of the three-phase system that the team at Oak Ridge developed. What we are hoping is that under certain aspects that we will still receive a very high power transfer and a clean power transfer rate. So that's something that we hope to gain out of this project. And certainly the pure power level is already a very good selling factor.
This project isn't the first time Volkswagen has collaborated with ORNL. Here's Hendrik Meinke.
The collaboration with Oak Ridge National Lab and Volkswagen Group started pretty much 10 years ago. At that time, we were looking in projects of mostly materials. For example, low-cost carbon fiber was one of the first projects with Oak Ridge National Labs. And over the last 10 years, it has developed to projects in sustainability, power electronics, and basically wireless charging is the last project in a long line of collaboration projects from Volkswagen with Oak Ridge National Lab. And definitely one of the highlight projects Volkswagen Group Innovation has right now is a 270 kilowatt wireless power transfer project with Oak Ridge National Lab, equipping a Porsche Taycan with this awesome technology.
While Oak Ridge is behind the research and development of this technology, you won't see any ORNL branded wireless charging systems on the market in the future.
At ORNL, we develop technologies and we get patents. We publish out of papers, and our patents are available for licensing. We're not here to create products. We're not going to manufacture anything. We're not going to build wireless charging systems and sell them. So we're open for business, working with the industry. All we're trying to do is we're trying to develop the technologies that will accelerate the adoption of wireless charging and electrified transportation so that they will be everywhere, and we can have a maybe small impact on climate change and decarbonization.
The lab's wireless charging technology caught the attention of a company named Hevo.
Hevo is a Brooklyn-based technology company that is working to develop and commercialize wireless charging systems.
We started with our own development. Once we got to a point where we could commercialize that, people started to hear about us. And Oak Ridge and Hevo, we had known each other for a while. We hadn't actually ever met. And we knew the team. We knew they had a great team. But we made a decision to talk with each other and find out where we were both at. And what we realized that there was an opportunity there because Hevo had developed a commercializable level 2 system. And they had this high power system that could also do vehicle to grid and drive and charge at the same time. So what we realized was, hey, we're a commercial company. You're an R&D organization. What if we came together and Hevo became your commercial partner? So one thing led to another. And about 6 months later, after those initial discussions, we executed our framework agreement.
That's Jeremy McCool, the founder and CEO of Hevo.
Hevo licensed ORNL's wireless charging technology in August of 2021, and they didn't stop there. Jeremy's team is collaborating with ORNL to continue to push the technology forward.
We felt excited about what we could do together because when you pack on what we know is required to take a technology out of laboratory into commercialization and all the process in between, and you add that to the powerhouse that is the Oak Ridge National Laboratory team and all their skills, it's like taking an engineering team and tripling it in size and scope and breadth overnight. So major automakers, major energy companies from around the world, not just in the United States, they come to Oak Ridge because they understand in principle, they're going to get the best of the best out of that facility and that organization. And so we understood Hevo being the best in class, we were going to be working with the best of the best. And the fact is the best only wants to work with the best.
This partnership and collaboration means that wireless charging technology is poised to hit the market in just a few years.
We look at the total market sizing. It's a bit over 5 million electric vehicles in the world today. It's going to triple in size in just the next couple of years. And by the time wireless charging is made standard package on electric vehicles, which is around 2024, 2025, we'll start to see major automakers around that time start to roll out wireless charging on vehicles. We'll already have at least provided opportunities for people that want to drive electric vehicles today with wireless charging to be able to get it on as an aftermarket product. Usually it'll be done by either their dealership that they bought the car from or from another third-party electric vehicle mechanic that was certified by Hevo. Then working in parallel with that with all the major automakers that we're engaged with right now to commercialize wireless EV charging with their stated timelines being 2024, 2025 for the first vehicles to have it as a factory built-in solution and start rolling it out for customers to experience and enjoy. And so we're not too far away from that happening.
Thank you for listening to this episode of The Sound of Science.
We hope you enjoyed it and will leave us a review wherever you get your